In this video, I'm going to be talking about the most important concepts to know within AWS. And in order to explain this, I'm going to create an architecture diagram for a highly available and highly scalable web application, just to demonstrate each of the important concepts within AWS. So this video is for anybody who is looking to understand more of AWS cloud computing, and just understanding the basics, or it's for anybody who is looking to just get a refresher on the core AWS services and building applications in AWS. So to start off my application architecture, I'm first going to deploy the EC2 instances. And this is the core building block for my application in AWS. So EC2 is Elastic Cloud Compute. You can think of this as renting a server over the internet. So this is your own personal server or computer that you can run in the cloud. So when you are going to create an EC2 instance, what you're going to do is you're going to give it a name, for example. So you can add a name if you want. You don't have to. This is optional, but it's just easier to kind of differentiate the instance. And then the next thing that you're going to do is you're going to define an AMI for that instance. And so the AMI is going to be the operating system that this instance is going to be used. There are a lot of different vendors that provide AMIs that can be used within AWS. For example, there's Red Hat, there's Ubuntu, there's Amazon, where they provide Amazon Linux. So many different vendors provide their AMIs, which include the operating system and the respective packages. So you'll define the AMI, and then after that, you're going to define the instance type, which the instance is going to use. So the instance type is essentially, you're defining the amount of vCPUs that you want to use, the memory, so just the compute capacity requirements that you're providing for the instance, and the architecture that you're going to be using. So there's instance types for AMD 64 or for ARM. So you get to define, which instance type you're going to use based on the requirements that you have. So after you define the instance type, what you're going to do is define the networking for the instance. So this will include things like the security groups, the subnets, and the VPC. So security groups are essentially a firewall that you get to apply to your EC2 instance. So you define in a security group what traffic is allowed inbound and what traffic is allowed outbound. Next is subnets. So first you're going to create a VPC, which is just your own private network within the cloud. And within the VPC, you create subnets, which are essentially smaller networks within that VPC. And in the subnets, you define a specific CIDR range that's going to be carved out of the VPC CIDR range. So when you create a subnet, you essentially define which availability zone that subnet is going to be in. So with availability zones, you have like US East 1, for example. So say US East 1. So this is the US East is the geographic location. So you have US East or US West. So these are the geographic locations, and then within each geographic location, you have your availability zones. So for example, you have US East 1A, US East 1B, and these are just the different data centers that are located within that region. So what I'll do here is I'll separate this instance within an availability zone. So for example, this instance is going to be in US East 1A. Okay, so when you create your EC2 instance and define a subnet, you can, for example, create one instance in US East 1A. And you can create one instance in we'll say US East 1B. And this is just essentially to enable high availability. So let's say you have your application running, in US East 1A and US East 1B. So if one of those availability zones, goes down, or if your application has issues in one availability zone, then the other availability zone and application can handle the requests during that time. So the next thing that we want to consider when building this application is high availability. And, we can do this by having multiple availability zones, but we want the application to be able to scale. For example, let's say that your application experiences a huge spike in requests, and the application has an increase in CPU usage trying to handle those requests. So you may see that users, when they're trying to access the application, are going to have errors or timeouts, for example, and this is because the server is going to be overloaded. So in order to mitigate this or prevent this from happening, what we can do is we can add an auto scaling group. So what you would do is you would place the instances within an auto scaling group, define a launch template which has the configuration for the AMI, the instance type, security groups, subnets, all of that, and you set a desired count, and you set a minimum count and a maximum count, so the auto scaling group can scale up if it needs to, and it can scale down if it needs to based on demand. So in order to configure this, dynamic scaling with the EC2 instances in an auto scaling group, when you're creating the auto scaling group, what you can do is select a scaling policy. So the scaling policy is going to be responsible for defining the metric for scaling the auto scaling group. So when you're configuring the scaling policy, you can define something like a target track scaling policy. Okay, so the target track scaling policy, when you're configuring this, what you'll do is you'll define a target metric. So say, for example, CPU usage. And what you do is you define the average CPU usage. And if the usage goes above that level that you've defined, then the auto scaling group is going to scale out. And if it goes below that level you defined, then the auto scaling group will scale in. So let's say that you're configuring a target track scaling policy for the auto scaling group, and you set the average CPU utilization to, let's say, 50%. So AWS will define or create thresholds for that target track scaling automatically. So, when the CPU usage goes above that 50% that you define, then there's a threshold before it will start scaling up. And the same thing when scaling down. So we have the target track scaling policy for CPU. And what that's going to do is when the CPU is spiking, these instances are going to scale out. So I'll add a new instance here, and we'll say that this is US East 1, say C. Okay, US East 1C. So when the auto scaling group is scaling out based on the increased usage, it's only able to scale out to the maximum value that you set for your auto scaling group. So if you set a minimum value of let's say 1, maximum value of 5, it can only scale out to a maximum of 5 instances at most. So that's one thing to consider. But let's say that the traffic increased and now it's able to scale up to 3 instances instead of just 1 or 2 instances. So what this does is, traffic is able to now be spread out across these instances. So if one instance goes down, then the other instances are able to handle the traffic. So one thing we need to note is, how is the traffic actually going to get spread out across these instances, and how is the traffic going to reach the instances? So for this, what we're going to use is load balancing. So we'll add the load balancer resource here. And so what exactly is load balancing, right? So load balancing allows you to distribute the traffic evenly among the EC2 instances that are running in your environment. So with Elastic Load Balancing, you can configure the targets to be the auto scaling group. So it'll automatically register the EC2 targets and distribute traffic among them. So how it works is traffic will come to the load balancer, and then the load balancer will distribute the traffic among the EC2 targets in this auto scaling group. So, and it does this in sort of a round robin style fashion. So it'll send traffic to this instance, and then the next request goes to this one. Next request goes to this one. So this is a way that we can make sure that the traffic is evenly distributed and one EC2 instance isn't getting overloaded with all of their requests. Also, another thing that I wanted to note about auto scaling is that it has health check capabilities as well. So what you can do is you can configure health checks with the auto scaling configuration and the target groups, where it will send a request to each target over a specified port or protocol. And if that request is not returned successfully, then it will mark the instance as unhealthy. So in that case, when it's marked as unhealthy, it's not going to forward traffic to that instance. And eventually that instance is going to get replaced by the auto scaling group. All right, now that we've talked about auto scaling here and elastic load balancing, the next thing that we're going to talk about is the DNS resolution within AWS. So AWS uses what's called Route 53 for DNS resolution. So I'll add this here. And Route 53 is the DNS server of AWS. So it gives you the capabilities for resolving the IP addresses to friendly domain names. So in this case, we'll have Route 53, which, within Route 53, you can create records. For example, you have A records or AAAA records, CNAME records, and then within AWS Route 53, there's a what's called an alias record. This is going to be Route 53 specific, and it essentially allows you to map a domain name to an AWS resource, like Elastic Load Balancing. So in this case, what we would do is we would route or we would create an alias record, which would be mapped to this application load balancer or network load balancer, whatever it may be. And then that traffic will be routed based on the domain name. So in this case, we would create a Route 53 alias record, and we would map a specific domain name that we would want to use for the application website. We would map that to the application load balancer or network load balancer. In this case, it should be an application load balancer, but we'll map that alias record to the application load balancer. So then, when users are hitting that specific domain name, like example.com, then they'll get routed to that application load balancer, and then they would get routed to the actual application. Okay, so I'll just add the main records types that Route 53 offers. So there's the A records, and this is just the standard, you're mapping an IPv4 address to a domain name. Then there's the AAAA records, which is essentially just the same thing as an A record, but it's mapping an IPv6 address to a domain name instead. Okay, and then there's the CNAME records, which is essentially mapping one domain name to another domain name or a canonical domain. And then there are the alias records, which is Route 53 specific, as I mentioned. This is mapping the domain to an AWS resource like auto scaling. And then there's, there's MX records, which is going to be for email servers. And then, lastly, you might have like TXT records. And this is just to, associate arbitrary text with the DNS records. Okay, so the last thing that I wanted to note about Route 53 is that it offers an additional feature called routing policies. So if I go over to the documentation here, so you can create a routing policy or choose a routing policy when you create a record within Route 53. And this routing policy determines how traffic is routed and how Route 53 responds to queries. So, a few examples, right? So there's failover routing. So if you want to configure failover, for example, you have resources that are not responding to health checks performed by Route 53, and they're marked as unhealthy, then you can have Route 53 failover to a different resource. Say, for example, you have an auto scaling group in one region, and say, for example, you have a load balancer in one region and a load balancer in another region, and both of those are behind Route 53 using the failover routing policy. Well, then, when one resource or one load balancer becomes unhealthy, and then one load balancer becomes unhealthy and Route 53 detects that, it'll automatically start routing requests to the other domain or resource that it has in the different region. And then next, there's other things like geolocation routing, which is able to route traffic based on the location of your users. Geoproximity is routing traffic based on the location of your resources. And then latency-based routing as well, where you can route traffic to the region that provides the best, lowest latency for the user. And then there's a couple other routing policies as well. But these are all really cool features that Route 53 offers. All right, so now going back to the architecture diagram. So the next thing that I wanted to address here is the storage requirements for the application. So what we're going to introduce here is first, we'll introduce DynamoDB. Okay, so we'll put DynamoDB down here. So what exactly is DynamoDB? So this is a database, and this database is essentially used for storing data in table-like format, and it uses key value pairs. So within this application, what I'm going to use it for is we'll say this is an e-commerce application, for example. And we'll use it for the cart information. So when users save an item to their cart, then that will be stored and retrieved from DynamoDB. All right, so and the reason that we're using DynamoDB for this for the cart in this application is because DynamoDB has super high performance for one. So if the application needs to scale and handle a ton of users during, for example, like a holiday season where many requests are being made and there's expected high traffic where people are adding a lot of items to their cart. DynamoDB is very scalable and it is very high performing. So with DynamoDB, the cart is going to update immediately, and there is no need for complex queries against a database. So on the other hand, we have a database called RDS. So RDS is another popular option which is commonly used within AWS. And within this diagram and application, RDS is going to be used for storing information about users, and let's say, for example, their credit card information for buying things on the website, their address, phone number, things like that. So RDS is good for if you need to store data that has relation. It's a relational database. So, relational data like the users and their credit card information and, all of the things that are associated with that user. It's going to be perfect for RDS. So RDS is also good for running complex queries. It's an SQL-based database. So, you can run complex queries to identify the user and their specific attributes, for example. So RDS and DynamoDB are going to run within the private subnets of the VPC. So we'll give it a subnet here, and then we'll just duplicate that for DynamoDB as well. And then I'll just label this as well. So let's say RDS, say RDS, and then we'll say DynamoDB. Okay, so we have RDS and DynamoDB being used by the application for storing user information and storing the user's cart information. Okay, and I'll just label these as private subnets as well. Perfect. Okay, and actually to simplify this, I'm just going to put this all within the same subnet configuration. So put RDS over here and remove this arrow. All right, perfect. All right, so now at this point, we have the application and all of these components here, but we need somebody who is able to manage this application and somebody who has access to work with these resources and manage the different services that are associated. So in order to do that, we need to use a service called IAM. So IAM is identity and access management, and this is essentially where you're going to create your users, your groups, and assign permissions to those users and groups, or you can create roles as well and assign permissions to those roles. So in this scenario, what we can do is we can create an IAM user, and we'll just say that this is the application management group, or user rather. So with this user, what we have to do is we have to assign IAM permissions. So let me go ahead and grab the icon for permissions. So the permissions here are going to be the permissions that the user needs in order to interact with each of the resources in this account. So, it would need permissions to manage the EC2 resources, permissions for load balancing, permissions for Route 53, permissions for RDS and DynamoDB. So you can add all of that to what's called an IAM policy. So, you create an IAM policy, and then you would attach that policy to the IAM user, and then that user would then be able to perform, those respective actions. So another way that you can do this is you can create an IAM group. So we'll just label this IAM group. Okay. And when you have your IAM group, you can add any IAM users to this group, and you would attach the permissions directly to this group. So for example, you could have a group called developers, and you would add all of the developer users to this specific group so that they have the permissions needed to perform whatever the development operations may be. So here you would have the IAM permissions. I'll just copy that, put it down here, and you would attach that to the IAM group. Okay, so we'll put this into its own little container over here. So this is the IAM configuration. All right, now, so the next thing that I want to do here is I want to add monitoring components within the environment so I can see, what's going on with those EC2 instances, get logs and monitor the metrics, for example. So in order to do this, we can use a service called CloudWatch. So I'll add the CloudWatch icon here. So within CloudWatch, what we can do is we can install the CloudWatch agent on the EC2 instances, and the CloudWatch agent is going to collect the metric and log information from the EC2 instances. So it'll collect like system logs, var log information, and it will collect the metrics like CPU usage, disk usage, memory usage, and some additional network metrics. And that information will be forwarded to the CloudWatch console where you can view it and just get information on what exactly is happening with the instance. So here we'll have the CloudWatch monitoring the instances, and then we'll also have to install the CloudWatch agent on the instances themselves so that this information can be forwarded. And I'll just go ahead and reverse this. Okay, so I'll put a little CloudWatch icon over here to just kind of demonstrate the CloudWatch agent. So insert a text box here. CloudWatch agent. Okay. Okay, so I'll go ahead and duplicate this. All right. So essentially, in order to install the CloudWatch agent on these EC2 instances, what we'd have to do is within the auto scaling group launch template, we would have to configure user data. So user data is a command or a set of commands that is run on the instance at launch. And you can add things, like installing certain packages, for example. But in the user data, we would configure the commands to install and configure the CloudWatch agent. And whenever those new instances are started, then the CloudWatch agent will automatically get installed and configured on the instances. So then, that's a way to automate the CloudWatch configuration and then have those logs and metrics sent to CloudWatch console. So I'll just add a little note here, install CloudWatch agent with launch template user data. Okay. All right, so now let's say that I wanted to store the CloudWatch logs for a longer period of time. All right, so within CloudWatch, the logs are only stored for about 90 days. So after that period of time, you wouldn't be able to view them. So let's say that you wanted to store these logs for a much longer period of time. Maybe you have compliance requirements, or you just want to be able to view the logs past 90 days. So in order to do that, we're going to use S3 storage. So we'll configure CloudWatch to store the CloudWatch logs into an S3 bucket. So I'll just go ahead and label this S3. So S3 is an object storage type service. So you can store things like media files, logs, pictures, for example. And it's super highly scalable and highly available. So you can be sure that your data is going to be safe when stored in there. So one common use case for S3 is to host a static website. So it's great for hosting a static website where you're serving content like HTML code, or just hosting images or videos, just content that's not dynamic and doesn't need a full-on application for it, but you're just hosting simple media files or content. All right, so that was my demonstration and explanation of some of the most important services within AWS. So I hoped that you learned something valuable from this, and if you enjoyed watching this video, please feel free to give it a like and subscribe. Thank you.